I'm whurley. I'm CEO, founder of Strangeworks. We're a quantum computing and advanced computing software company in Austin, Texas. And a long time ago, I had this crazy idea, which was I'm going to create an open source Linux Foundation project to make quantum easy for everybody. And that was a big hunk of bullshit. Nobody wanted to participate. Nobody wanted to fund it. I tried to start an IEEE standards group for quantum computing. Nobody wanted a standard. And then I was going to you know what, I'm going to help developers make this really simple. What I learned is you can't take a quantum developer and turn them into a quantum developer. So I wrote 2 books, Quantum Computing for Babies, which is the best book, and then Quantum Computing for Dummies. And then that went into German as if the Quantum Computing for Dummies book wasn't complicated enough already to begin with. And so we're going to rock through a whole bunch of stuff. So the first thing is, yes, the quantum revolution is here. No, it's not as far along as you might think. It's 125 years of quantum mechanics, all coming up to kind of this fruition. I mean, we've had companies that have worked on quantum computers for 60, 70 years at this point, okay? And you probably see the news, it's like great discoveries. There's this huge disconnect between quantum and reality, and that is that if you move a Rydberg atom a few nanometers away and you hold entanglement, that's a huge scientific thing, but then it goes in the press like scientists discover a new way to, that doesn't make it a quantum computer, right? These things, as we'll talk about, have a lot of issues. But we are moving from science fiction to science fact. There are dozens of publicly traded companies in the quantum space right now, most of them not making any kind of killer revenues. Most of the revenues actually coming from classical work, or what we call hybrid work, where you do all the classical work and then you pump it through a quantum machine. But it's a huge, huge area. So as you can see here, $2 trillion in economic value is what the World Economic Forum is thinking by 2035, 1.3 trillion, 1 trillion, all these huge numbers. And you see all these countries investing in it. China being the biggest investor in it by far. And so you might look at that 625 for America and be like, well, that doesn't seem right, because I saw that the Biden administration did $1.5 billion, and then Trump administration did even more, but there's a difference between appropriations and authorizations. And so that's actual money spent. And that's pretty sad, because I gave a keynote in Abu Dhabi at the end of last year, and the king said, the UAE said, there's going to be very soon 2 types of countries in the world, those that have quantum and those that don't. And so if you look at it from an investment perspective, you'll see that since 2011, there's been $10.1 billion invested in quantum. Last year, 8.33, and actually that number could be updated to 9.4. So that's $9.4 billion invested in one 365-day period. So clearly there's something happening, right? And so why do we care about quantum? Why does it matter? Why it matters is that this is the first step away from von Neumann architectures, the first step away from the transistor invented in 1959 by Jack Kilby at Texas Instruments. In the history of computers, we've never really changed the underlying underpinnings of how computers work. 1959, Jack Kilby invents the integrated circuit. Before that, you bought transistors one at a time because they went into transistor radios. From that time to NVIDIA's announcements at GTC last week, all kind of the same, right? You have 4 bits, you have 16 outcomes, you can be in one of those outcomes at any given moment in time, period. You add a 5th bit, you got 25, you can be in one. Now, think about something like taking a salt atom, blowing it up in a vacuum chamber, pulling an electron off, freezing it colder than space to almost 0 Kelvin, or trapping it with lasers, or any one of a number of techniques we can use to hold that particle in place. And now we have 4 qubits. And the difference is we can be in all 16 outcomes at the same exact moment in time, okay? And if we add a qubit, we then have 2 to the n the number of bits in that system. These things are unbelievably powerful. They're not going to run cat videos on YouTube. They are going to find not cures for disease, but ways to eliminate disease, right? Not better batteries, but completely new forms of energy. And there's over 100 Fortune 500 companies that have quantum programs right now today. And they're small, let's be honest. They're innovation groups, there's scientists doing stuff. We work at Strangeworks with a lot of companies in pharmaceutical and aerospace and defense and others, but the programs are still somewhat fairly small. I think all of that changes, because if we look at the state of this today, then we have to look at, well, who are the players and what are they building? So there are dozens of ways to make a quantum computer. The leading hardware approaches are superconducting qubits, trapped ions, neutral atoms, quantum photonics, and silicon. You can see all of the players there. Most of them you've never heard of. Almost all of them are either public now or going public in the next year. Some of them are looking at de-SPACing in the next few months. Lots of great companies. Superconducting qubits, those are those quantum computers you've seen online that look like chandeliers. All the quantum computer is at the bottom is that little chip about the size of my thumbnail. The rest of that's cryogenics to cool it down to almost 0 Kelvin. Trapped ions look like nice little rack mount slick units. They're all different. I think silicon spin has some unique advantages because it's CMOS technology, which means it can be fabbed anywhere. You don't need a new fab. But there's also some alternative hardware approaches. There's quantum annealing from D-Wave, which is one of the oldest companies in the space. And then there's this new thing called quantum inspired, where the Japanese, who are extremely advanced on quantum, have taken all the ideas of quantum mechanics and put it down into actual hardware that kind of simulates that. But it's really cheap and really affordable and can do some pretty cool stuff. Significant milestones. IBM reached 1121 qubits. Yay. As a developer, that's still not that useful to me. Microsoft discovered a new form of matter that they're going to use to power their topological quantum computer and make it a reality. But the big one is December 2024. All of these companies that went public are trading at 70 to 90 cents. They're getting delisting letters. Everybody's starting to say quantum's going to go into another cycle. Google did a paper in August on their Willow chip. In December, they make a slick video and they post it. Their market cap goes up by $300 billion in less than 96 hours. Every algorithmic trader said find quantum, publicly traded companies, and companies that were worth 100 million were worth billions of dollars overnight. Some of them well-deserving, others of them make a couple $100,000 a year last year in revenue and they're worth 3.5 billion. So clearly, I am doing something wrong. I don't know what that is. And there's a growing software ecosystem, right? You guys want to go play with this stuff. Google has Qiskit, IBM has Qiskit, Microsoft has Q-Sharp, and of course NVIDIA has CUDA Quantum, all frameworks that you can use to go and try to play with these technologies. But access and abstraction are critical. Again, you can't take a quantum developer and a regular developer and turn them into a quantum developer. It's nearly impossible. And so we need more open source programs. We need more integration with AI, which I'll talk about in a moment. But what are these quantum computers going to do? Why have I taken what Mark jokingly says is the end of my career, which almost happened with the robot, and because that would have been really bad. My girlfriend at the time and her father, who I had never met, were standing and it went straight towards them. And I was like, oh, this is relationship ending and career ending. But what am I excited about? Well, the thing everybody wants me to talk about that I'm not excited about is Bitcoin. And when does quantum computing break encryption? Listen, people, we used to have a machine called the Enigma machine. Nobody uses that anymore, okay? So it's going to break encryption. There's going to be something else. Security is fundamentally flawed in that we never expected computers to get super powerful. So we're like, make it take a lot of processing time and money, and we're done. And that's a horrible way to secure information. But here's what you'll find interesting. We don't understand quantum mechanics, meaning that every year, as we learn more about the power of these qubits, we learn more about the application of them. So in 2024, it was going to take 6 million qubits, which we are way away from, to break encryption. Last year, that went to 1 million. This year, that went to 100,000. Okay? So you're looking at an exponential collapse in the number of qubits. And my bet is, by next year or the year after, it'll be 50 or 60,000. Now you can start seeing an intersection point between how many qubits we're being able to build and keep entangled and that breaking of encryption. So that's something that's going to happen. But here's the things I'm interested in. Again, not finding a new drug discovery, but eliminating a disease. That is actually in reach with this technology. Not, finding ways to build new materials that do things, but like replacing plastic and other things in the environment. Amazing material science can be done. You want to go to Mars? Probably not actually happening without a lot of this. The material science of space and interplanetary stuff is mind-boggling complex. I know we have a customer that does it, and I don't understand 99% of it. Finance and optimization. One person having the power of a citadel, or 0.72. And so these are earth-shattering changes. And Mark made a comment. He said, things aren't necessarily evenly distributed, right? And what worries me and why I started Strangeworks was that this technology is going to come out, but we're not going to have the access for everyone, both from a technological capability, people aren't going to understand how to use them, and from a financial perspective, from all kind of manners. And so I really want to crack that open. I gave a presentation, you can go check it online, youtube.com/whurley, and it's about a power of 1 billion minds. And this is what I see for quantum. Imagine if 1 billion people, like if we took all the scientists in the world and all the scientific funding and everyone who could spell science, and we made that a house key, and we took that house key and we went out to a soccer pitch, or I was raised in Germany, so a football field, and we threw that key in the middle of the field. That key would represent all of science participation, and that field would represent the rest of humanity. So imagine if we took and had 1 billion people with access to this technology through the power of AI, so that they don't have to know how the quantum computers necessarily work. So they can have this kind of, GIN interface if you want. Imagine if we did that, and we had 1 billion people come in with ideas on how to solve the problems in the world, right? It would change our species forever. So when we look at navigating it, we've got a bunch of hurdles. Decoherence and quantum noise. When you entangle these particles, it's hard to keep them in that state. And once they decohere, it's not really a quantum computer anymore. Decoherence times, how long you ask? I think somebody asked. 1 second to 40 seconds, depending on the architecture of the machine. That means as a software developer, I have to write a gate that is going to complete before that machine disappears from the space-time, right? So again, it's still a little complex right now. Error correction, kind of a thing, kind of not. We don't really have that in quantum computers. That means fault tolerance isn't so good. It's not running for 24 hours. It's running till it decoheres, and then we have to get it back into that entangled state again. And scaling qubits is hard. If you go back to when I started Strangeworks, we were promised 1 million qubits by 2 years ago, and desktop, and none of that has happened, because it turns out super, super hard science. But we are getting there, and it is moving a lot faster. The one I'm interested in is new programming paradigms, and that leads into the fact that there's a talent and education gap in this, and that we have not democratized access. When we started Strangeworks, our whole thing was humanizing quantum, like making it easy for people to understand, making it easy for people to be able to get access to and do stuff with. It's been a challenge, but we're still on it. So that leads us to what we want to talk about, the role of intelligent agents, and the convergence of quantum and AI. Now, 8 years ago, when I said AI and quantum were going to converge, I got harassed by the AI people, and I got harassed by the quantum people, okay? And I literally have people on video, because I'm waiting for them to call me out on this, where I can just like, you know what, I have a video on my phone of you saying this, boop. AI is trying to recreate a human brain. Let's just call it what it is. And human brains come from nature, and nature is quantum mechanical. So in the AI case, we're trying to duplicate nature, and in the quantum case, we're using nature as the new substrate to compute on. So I think these technologies naturally go together, and when you look at the complexity of quantum, when you look at what these machines take to operate, to maintain the entanglement, for you to program it, I think this is unbelievably the obvious big opportunity for artificial intelligence. And I don't think you get to superintelligence without it. I will take a bet now, LLMs do not lead to AGI, no matter what anybody has convinced you, okay? Just that doesn't make any sense from a software perspective or a math perspective or any perspective. So why does artificial intelligence change everything? It changes everything because at Strangeworks, we were years ago immediately able to take the Gen AI stuff and take all the complexity of quantum and push it into the background and let you just be like, I have a problem, and start talking to the machine. Because quantum research is difficult. We talked about the talent gap. There's not that many people that can do this. So how are we going to discover new circuits for material science, or new circuits for eliminating a disease? So we need automated circuit design, which AI would be phenomenal at. We need error correction and noise, which it's already being applied to. And we need to optimize quantum experiments. we're still learning about this landscape, and what better technology to explore this landscape with than AI? And agents are going to boost capabilities, right? And vice versa. We're going to have faster pattern recognition. We're going to have accelerated search and optimization. Optimization is probably the thing, if I were interested in quantum, I would focus on first. And it won't be the near distant future, but there's quantum native agents and some new paradigms around intelligence. Again, I don't think you get to supercomputing without this. So, getting you ready to prepare for tomorrow, there's a ton of learning resources out there. I'm actually don't stay at conferences, but I'll be here till tomorrow. I'm happy to answer any questions. This is my whole life's work, is evangelizing this and getting as many of you involved in this by the time you leave the conference as possible. There's a bunch of experimentation you can do, and if you're in a business, you have to start thinking about a quantum-ready team. It doesn't matter if you're a security expert in that business. It doesn't matter if you're a software developer or an enterprise leader. It's super, super important. And there's a lot of security implications to consider, and there's some really crazy ethical frameworks we need to think about. Nick Farina at AeroQ and his partner Faye have done an amazing job on this. If you go Google their stuff in quantum ethics, you're talking about a technology that will reshape global power. It will change the entire world economy. Everything we know about science, scientific discovery being accelerated at an unbelievable exponential pace. And there's a lot of potential downsides for that, right? So I want you to take 3 things away. I want you to understand that it's here, it's got transformative potential, but it's not quite, there yet. I want you to know that AI agents are the key to unlocking this quantum future, in my opinion. And a lot of companies in the space are working with them. We like to think we're one of the best. Happy to answer questions about that at some point. And I want you to understand that it's important for you to be involved. This is the first step in a new form of technology for computing, which we have become completely, unbelievably dependent upon. And it is a huge step, and we're likely to step right off a cliff if we don't have enough people involved. And so explore those resources, experiment with everything, connect with the community, and understand that this is a gigantic global effort. Every country, now these are just a few, there are 50 plus countries working on quantum to try to be the first. Some of them for great reasons, some of them for not so great reasons, right? Authoritarian regimes tend to move much faster in quantum. I'm not sure why, but there's some kind of work incentive there, like kill your family. But this is your invitation to think bigger and binary.